it doesn't, I can show sort of the journey I took with another flake. So I'm starting out from the perspective of I want to figure out what the flakiest tests in the project are. I can do that by going to, sorry, not the monitoring board, this website called velodrome.kubernetes.io. It's basically a Grafana instance pointed at an influx database that is populated by Prometheus and a bunch of jobs that run queries against BigQuery and dump the results in influx. So I just showed this at my previous talk. This dashboard is focused specifically on pull requests into the Kubernetes repo. And I can see things like the PR jobs that have been failing for the longest, although I wouldn't trust the fidelity of this data. Really, the things that I'm most interested in are the flakiest PR jobs table, which shows in sorted order which jobs have been failing or flaking the most in the past week. And then for each of those jobs, what are the two most prominent flakes? So right away here, we can see one of the complaints I personally have, and maybe some of you have with this dashboard, is like, what does timeout mean? How can I do anything with timeout? And same thing with teardown. What does that even mean? And the unfortunate thing is these are often meta parts of the job in question. We can go find this job by going to test grid, and I'll go take a look at E2E cops AWS and see what comes up. It's in the pre-submits Kubernetes blocking dashboard. I will hit enter. It takes a while to load in these results because there are a lot of them. So test grid basically shows a row for each and every single test case and a column for each and every single run. The pre-submits are generally never expected to pass 100% of the time because this just sort of represents a bunch of runs for different pull requests. So I wouldn't expect any sort of real linearity to this test grid thing. Test grid, though, does generally order least recent to the right, most recent to the left. And then we add in a bunch of extra sort of meta test cases in addition to the actual test cases for like the overall job status, as well as individual phases like bringing up a cluster, tearing down a cluster, so on and so forth. That's just to sort of give you some context on what timeout and teardown mean. For what it's worth, these most likely come from the tool that was used to stand up that cluster and run the tests. That tool is called kubetest. It lives inside of the Kubernetes test infra repo. It is written in Golang. Here's the README, and it basically describes how you run it with a bunch of different flags to stand up a cluster, run tests against that cluster, dump artifacts from that cluster, and finally tear the cluster down. And we also have timeout flags to say that you should consider the test running for too long to be a failure, and that failure will be for the test case called timeout. Test grid doesn't really have, or at least the way we use test grid today, it doesn't understand the concept of hierarchy. So that's why we inject this fake test case called overall, so that you can sort of very quickly like filter down to a regular expression. I will include filter by regex overall. And that just gives me an idea if the job itself is failing or not. Regex is case sensitive, so I'm probably going to have to use a capital O. Anyway, so this kind of confirms my insight that the Kubernetes kops AWS job is a little bit flaky. I'm actually not going to dive into why the timeout and teardown things are happening there. Let's see here. I'm trying to like cherry pick a good test case here if I can. Let's see if we can figure out what's going on with in-tree volumes and host path symlink. So the reason I'm cherry picking that for what it's worth is well, you know what? Let's try diving into test terminal pod eviction because Josh did promise at the last session that he would give me a gift if I managed to fix it. The first thing that I like to do when I'm chasing down a given test case, although it's not super going to apply for this one, is to use this tool we have called triage. So Triage also uses the same BigQuery data set that we use to generate these dashboards. Triage is responsible for looking at the failure text for each and every single test case. So when we run our tests, we generate JUnit files. Those JUnit files include information like did the test pass or not, how long did the test take to run, and what was standard out and standard error at the time that that test failed. We then take all of the failure text from every single one of those test cases across every single job. We then try to remove random things like pod IDs or timestamps or numbers to try and make the strings a little bit unique. And then we kind of see what failure texts look relatively similar to each other, and then we cluster those together. And that's what you get in this dashboard here. So this shows all of the failure clusters across. So this graph here is showing me all test failures across every single job that we have across the past 2 weeks. This big old thing here, for what it's worth, is from a single job where we were trying to mess around with whether or not we could do test coverage as a failure thing. And so we set up JUnit files that had true if we had better test coverage than our threshold, and false if we had worse test coverage than our threshold for every single file. And it turns out we really don't meet a lot of test coverage. And we thought the scale of these failures was not all that great. So if I ignore this with a wonderful, horrible regular expression, I'm going to try writing right now. So not true. This is what I'm using to just get a sense of the general status of failures all across all of our jobs. I think that looks about right. So this can give me an intuition, for example, that like things got relatively worse from a failure perspective around November 29th to December 4th. Probably not a huge surprise, because I think that's roughly when we lifted code freeze, and so we ended up exercising a lot more tests than usual. This checkbox here also shows that I'm only displaying test results from our CI jobs. If I use this checkbox, I'm now including the test results from our PRs. And since I was interested in deflaking that job from this dashboard, test terminal pod eviction, I'll start by looking at just the PRs. And ignoring the failure text, I'm going to look specifically for test terminal pod eviction and see what comes up. So each of these little spikes here indicates when one of these failures happened. I'll turn it on for CI just to see if I have any more data from like our periodic runs of the integration tests. And so now I can see that this really long line of text, this is apparently what the failure looks like. And my experience in dealing with a previous integration test failure tells me that I'm probably not actually going to see the failure inside of this test. So what I want to do is go look at a specific instance of this test failure so I can start to look at the exact logs that were generated. So I can do that. This shows me the last 5 failures of this specific test case, right? And it tells me the job that these failures happened on. And I get these little like spark lines also to sort of show me how the failures were distributed across all of the jobs that the failure happened on. I'll go ahead and post the most recent, or pick the most recent one because we're doing it live. So this has now linked me to Kubernetes. Kubernetes is our app that is open source but runs on App Engine and is responsible for displaying all of the artifacts that are generated from any one of our test runs. You're most interested in this from an end-to-end test run, but you can see here we're using it for integration tests as well. So when I say artifacts, I mean whatever lives in this directory. So artifacts can include things like the JSON file that we dump when we start the job, which shows things like what repo were we using when we ran this job, what revision of Kubernetes were we using when we ran this job, as well as some information for us from a troubleshooting perspective, though I don't think we've ever had to use this, like what node was the job running on, what was the name of the pod that ran the job. The finished JSON file shows something similar. It shows me information like what was the commit of the test infra repo, because generally the way jobs will often work is that we're standing up code in Kubernetes, but the code, like I pointed you to kubetest, for example, that's in Kubernetes test infra, and I might want to know the revision of that code as well. We can see that the result of this job was failure, also known as past false. I don't know why we have both of these here. I'm pretty sure it has something to do with Jenkins. And then finally, I have the build log. So this shows exactly what happens when the job ran on the job perspective. So if you were to run this job on your laptop, for example, like this is what you would get. And it shows how it's running a bunch of stuff, doing a bunch of things, cloning a repo, building some stuff, and then running some tests. And oh, hey, look, this text looks kind of familiar. Let's see if I can find test. What was the name of this test I'm going after again? Test terminal pod eviction. Yes, test terminal pod eviction. Well, dang it, you know what? It's not showing up here at all. That's kind of annoying. So what actually is in this log? I believe, since these are integration tests, now I'm totally just pulling this off the top of my head. I think integration tests with Kubernetes are responsible for standing up Kubernetes components locally, so usually like an etcd server and an API server, and running tests against just those things. They don't often exercise nodes or kubelets. So we're probably seeing the logs from etcd and the API server. I'm not sure if we're actually seeing the failure of the test case itself. So I'm going to go back to the artifacts directory and go even deeper and see what else I can see. So now I have all of the logs from etcd if I wanted them. I don't. And I also have these JUnit files that say JUnit standard out. One of them's small and one of them's huge. Let's see what the small one is. The small one seems to be telling me all of the different tests that it's running. So let's again look for the word eviction. Dang, it's not in here. The demo gods are not being kind to me. Okay, what if I look in this massive file? I'm not sure Chrome's gonna actually be super good about downloading this, and I don't know how good the internet is, so I'm gonna just download this to a local terminal. Cool, cool, cool. Conference Wi-Fi is actually pretty good. Are people finding this useful? Like, am I showing you tools you have not seen before or doing stuff you've never heard of before? Okay, good. Just wanted to make sure I'm not like off on a tangent here. So now I'm looking at the JUnit file with Vim, the text editor, to rule them all. I will look for the word eviction. Cool. Test concurrent eviction. No, that's not quite what I want. Terminal pod eviction. Cool. So I see the run thing, and I'm assuming eventually I will run into the fail case. Maybe. Fail. Okay, cool. And look at that. Right after the fail is the actual line that it failed at and the error message that it failed with. And so I really don't understand why some of the output lands in this file versus some of the output landing in build log versus landing in some other place. This is an oddity about integration tests that I just kind of recently discovered in exploring a different integration test failure. But this is how I have walked through to find the actual failure, which you probably can't see it, appears to be expected the PDB generation to be of same value 1, but got 0. Like, I'd honestly like to find a way for this to be the text that shows up and is picked up by our triage cluster. This is also giving me a line of code that I could go take a look at, which I'll do. I'm not going to guarantee I have any idea like what the actual failure is, but just to prove that this is probably more useful. I'll admit I was honestly expecting this failure to be timed out waiting for condition, my favorite failure of all. Who here has run into timed out waiting for condition? Oh, wow, that's amazing. So timed out waiting for a condition comes from our utility code that just like waits until, and then you pass it a function. And nobody ever describes like what they are actually waiting for. They just pass the function and don't bother passing in a comment. And then further, the way that like our test code is architected, like generally you're calling a utility function that then calls the function that passes in the Golang that is the actual condition that's being waited upon. We can get into an issue that actually calls out that anti-pattern later. So sorry, I'm trying to get the latest code just in case I don't have whatever is causing that failure.
You can use code cell.
Oh my God, you're right. Thank you for making, yes, let's tie this all together. Expected the PDB generation to be of same value. I'm guessing that's the string that I can search for. Let's just see what happens without the slash. Cool. That's a vendor directory in Kubernetes CSI. Is there any way I can, oh, look. Cool, I was gonna ask from a demo perspective, is there any way I can like scope the search to a specific repo or something? Okay, cool. And then we said it was line 237, right here. Cool. So it's something to do with the pod disruption budget. This is the point where I'm not sure doing it live will help a whole lot. Like I can see there's a poll immediate happening in this test. This is good. It's actually doing a poll for something to happen instead of expecting an event to be sent to it. Events are not a guaranteed delivery thing. So oftentimes when you're setting up a test, you might watch for something to happen. That's okay. But if you're waiting for like, events are often sent from kubelets as part of the pod event lifecycle, I think. Pod lifecycle event generator, PLEG. And also the scheduler will often send events when it's like, I have decided to schedule this pod to this node because of this reason. That's super useful information, but unfortunately events as an API are not standardized or guaranteed, and when a cluster is under load, that guarantee falls apart. So this is often why the test might work well when you write it on your machine, but you start to see it flake at scale. But I digress, that's end-to-end, this is integration. I'm honestly not sure where I would take it from here.
Go back to the logs.
Sure.
I think it's not in the right fields. Scroll up.
Scroll, scroll, scroll. Using reconciler, parsed scheme, scheme not parsed. It's definitely like sitting here waiting for a bunch of this stuff. I'm not sure. I think really the.
Look there, connection refused. And then.
Wow, look where. How did you see that? Failed to sync.
0993, yeah.
Yeah. Failed to sync PDB concurrent eviction requests, ... Connection refused. Yeah. I'm not entirely sure, but it is very possible that this is the problem that's causing this test. Maybe we're running too many integration tests, and each of them may be standing at their own etcd server, and we need to find a way to run fewer of them all at once. I guess I'm trying to say, like, I kind of want to kick out of this live demo at this point. The main thing I wanted to demonstrate is how I searched around all of those tools, and I eventually found the actual failure text instead of that huge, massive block of text. Are we cool with moving on? Okay.
Basically, the test needs to be changed to check the nil.
It could very well be. I expect it's a little more subtle than that. It does feel like it's a scale thing. Okay, let's see. So I've shown you triage. Some other things to know about triage. Each of these text boxes are regular expressions. So the test is a regular expression, the job is a regular expression. So if I want to get persnickety and call out like the GKE test jobs, I can by just putting GKE in the job regex, and now I kind of see every single job that has GKE in its name. I could do the same thing for AWS and see how all of those are doing. I could do the same thing for ingress and do it that way. I like to use this as a different or alternate perspective on how the tests are doing across the system as opposed to test grid. Test grid is more of a manual thing. This gives me a little bit more of an opportunity to drill down. I can also change how I sort through these test failures, looking by not just the count in the last day, but also sorting by the error message, what have you. We also went through a phase for a little while where each of these things of text ended up hashing to some string. So gave up waiting 5 minutes for pod. This seems like kind of a legit thing that wasn't happening a whole bunch and is happening way more now. I don't know. So I can use the link button here to link to this. So if I'm telling somebody, hey, I found a problem in this one test and it's not just isolated to this one job, it's actually happening everywhere, I can hand them this link. I can then, based on this text here, I can go search GitHub to see if anybody has filed an issue with that text. This is something we used in the past where we thought it would be a neat idea to have a bot automatically take a look at all of these test failure clusters, take the top 10 of them, and then automatically file a GitHub issue pointing back to this specific cluster and saying, hey, we've noticed this has happened a lot in the past week. Maybe somebody should fix it. I guess I bring that up because we could try that again, but we ended up kind of turning that off. And the reason we turned it off is because people generally weren't super responsive to that. I'm trying to get to a query to sort of help show that. So I'm going to look for all issues within the Kubernetes org. And I think the author might be Kate CI Robot. We'll find out. Nope, that's Kate. That's my last talk. I was talking about how Prow now submits pull requests to update itself. Kate's merge robot. It was, yeah. I think I'm trying to show like how this didn't entirely work out a ton. Failure cluster. Okay. Cool. So we filed about 553 of them. And you can see that a lot of them had the needs sig label applied, which is something our infrastructure does when the issue is first created and nobody as a human being has bothered to say, hey, I know that this particular failure should be addressed by this sig. And you'll find that they often just kind of aged out. Or people would be like, this isn't super useful. This is a great example of us aging it out and just automatically closing it after 90 days. May also be worth pointing out, this was actually way more aggressive than what FetaBot does now, where FetaBot just labels an issue as stale if it hasn't been active in 90 days, whereas we used to just outright close them.
Adam,
Yes?
why do we have just 2 weeks? Can we have more than 2 weeks?
So we can have 2 weeks. We actually initially just had 1 week. But it's worth pointing out that we only display 2 weeks at a time. There's this date box up here, so I can go see like what were things like when I was in Shanghai. I'm sure they were super smooth and fine. And so this will show view all clusters. So this is what the state of the world was like November 12th. So I found, personally, I tried expanding this range to like 3 weeks or 4 weeks. The dashboard starts to get a little less readable. I also personally find that as a human being, it's really useful to look at this graph and sort of understand that there's like, I don't know, I can divide it up into half. So I get a sense that like this project kind of has a rhythm to it. Morning Pacific time to evening Pacific time might be one of those rhythms, or understanding like relative to the day when a particularly large change was landed. Like I'd probably be really interested to understand what happened sometime on the morning of November 1st, for example. I also am not super sure what time zone these timestamps are in. I am actually guessing they are in UTC, but I don't know for sure. This would be a great example of where if somebody wanted to like dig in and adjust the code so that it actually put the timestamp here, that might really simplify things for people. And since I'm giving a call to action there, I will just point out the code that runs all of this is in the test info repo under a directory called triage. It's basically a bunch of Python. It has the best README I have ever seen. So maybe you want to help update the docs. That would be cool. But I happen to know that like the page itself just lives within GCS. It's pretty much just a static HTML page. But then it also reads its data from JSON files that are automatically dumped there. Those JSON files are dumped by a job, which I will try to find by going to SIG testing. Oh, I should have done the search box. Yes, sorry. I'm trying to like get better at like being dumb. And just trusting that search will work because search is great and fast. So if I search for triage, this is the test grid thing that I set up just to make sure that the job that's responsible for updating the data that page reads is updated every 20 minutes. This also kind of comes back to why it's 2 weeks worth of history. I found if I bumped it up to 4 weeks, you start to have to make that trade-off over how frequently do you want this page to update versus how long does it take the query to run. I could verify this by using this handy-dandy test duration minutes thing. If I change the size of the graph to super compact, I can see that oddly, for some reason, it was taking longer to run, and now it's taking less time to run. Maybe that's because we have less flakes now. That'd be great. And then if I click through to the actual build log, I can see the job that, or the logs from the job that show like what tests it's walking through for failures and how it's clustering all of this stuff. And that's all code that lives in the test infra triage directory. Again, I kind of feel like I want to jump out at this point and time check. How much time do we have left? Half an hour. Cool. Okay.
Well, actually, 25.
Okay. So I've harped on this a bunch, but oh, great. Some people already know what this one is. Yeah. So this is one of the things that makes it really, really difficult to understand what is actually failing. I think that triage dashboard is super helpful because if there is a specific failure text, it can help you identify that specific failure, and you may often see it across a bunch of jobs. When I see that every single test fails with the exact same failure text, it makes that dashboard useless. And so one of the things you can do to solve this is to at least change expect error not to have occurred to actually have a message that indicates what was being done when we were expecting the error not to have occurred. You can also use the triage dashboard to identify all of the tests where this happens and maybe chase down like these jobs, these tests. This might be a good maybe this will be a better demo of the spark lines, I don't know. But so this shows like just, it's kind of scattered across all of these tests. And I would really love to better identify like what's going on when we timed out waiting for condition in the in-tree volumes test. Yes?
So does the output show the most recent byline? Sorry. Does the output, like when it captures the message, also show the most recent byline? So for people who aren't super familiar with Ginkgo, there's a really awesome function in Ginkgo where you can just write by, and it's for like annotating the steps of your tests. In addition to like obviously individual, like adding individual error like step annotations, you can add like more granular, like by attempting to register the CRDs with the API server, and then you can have a couple steps there.
So in this case, it appears the answer is no, I think. I just clicked on the most recent run of that test totally randomly, and then I clicked on see the standard out or standard error that happened at the same time as that test, and I don't see a by.
So
Adding bylines would help.
Adding bylines to our code it would be probably super useful, and then making sure like we capture those, because it's like from two approaches. It makes it easier to figure out what went wrong at like kind of higher level, and I also find it makes it much easier to like write my tests. I write the bylines first, and then I write the actual functionality.
Okay. So we don't think that Ginkgo puts that in the output, so it's not actually captured in the JUnit output, which is ultimately what we're parsing. This seems like a super manual and lo-fi way of dealing with it, but I've also asked as a good first issue that people could go through and just search for the code where that happens and just add a failure message right next to it. So here I know that I expected the error not to have occurred when I was listing pod templates in this namespace. I legit don't know if this makes things better or worse. I guess what I'm trying to say is I'm not sure if this is worth all of the effort, but it certainly seems a lot better than what we have now. For what it's worth, I have also heard people use this as reason number one why we shouldn't be using Ginkgo at all for end-to-end tests, and they really wish we could just use a regular testing framework. There are issues related to that I can try searching for on the fly. But I did at least just want to point out that this is a good umbrella issue for this sort of thing if you have really almost no technical experience in this project whatsoever, but you kind of know how to at least read code, understand what the test is trying to do, and dump some text in there. Let me think. Mind blanked. I think there's another common anti-pattern. So one of the things we as a project could do is try and find anti-patterns like this and squash them. I think the only way this is really going to work, deflaking all of our tests, is if it's the sort of thing that can easily be spread out amongst the entire community. Expecting a select few people as individuals to have the time to go chase down each and every one of these failures will not work. I know this because people have tried to come to SIG testing to solve their testing problems. And the problem is, like, we know almost as little about what's happening as you might. You probably have a better shot of understanding why your test is failing because you have the subject matter expertise about what the test is trying to do. We can only reason about the infrastructure and stuff that's wrapped all around of that test, but we probably don't have as deep of an understanding of logically what the test is trying to do and why. So
half the time people come here to SIG testing because
it's not their test that's failing, right?
yes. So we'll get to how you could maybe triage that. So another one of the anti-patterns that I called out earlier, and we sort of, I guess personally I have known about this for a while, but I'm glad that Josh has become aware of it as well during his efforts as a CI signal lead for 113. Okay, so credit to Michelle Law for figuring out this was why the storage tests failed. Like I said earlier, event delivery is not guaranteed. So if you have a test that actually is waiting for an event as your check, it's going to fail at scale. That's just the way it works. So that kind of reminds me of another thing that I can thank DIMS for, though I don't think I can actually deliver on the success of this effort. The flake attempts, yeah. So we also decided at one point that maybe we should just accept the world as the way it is, that it's a distributed system, the network is never perfectly reliable, and maybe we should just always rerun the tests twice. Because if it failed the first time, maybe it'll pass the second time, and then we don't have to bother fixing the problem. The concern is that this is now hiding just how many of our tests are poorly written and hit issues like this. So we actually, if I remember right, somebody told me we petitioned upstream to Ginkgo to add a flag to say retry attempts just so we could do this. DIMS put together a job that I probably won't be able to find, but I will try. Nope. Basically, the point, yeah, I'm not going to be able to find it right now. The point I'm trying to drive to is that of, maybe if I look for a flake. Oh, God. Everything.
Try flake attempt.
I think I maybe linked it here. Yes, here we go. Okay, and this is the umbrella issue I was trying to get to. So Dim's tried, like, what if we just set flake attempts to 1? So we're only going to try to run the tests once, and if they fail, they fail, and now we'll know what the actual flakes and failures are. This will give us a more realistic picture of what the problem is. Let's go see what the job name is so I can go search test grid for this. It's called single flake attempt. Are you all ready for how revealing this will be? Single flake attempt. Oh, we've hit a timeout. In fact, we've hit a timeout for as long as this test has been running. I looked at this up like a month ago, realized this was happening, and then never actually got around to fixing it. If somebody wants to PN a longer timeout for this job, like right now, totally land it. But so more broadly speaking, like oftentimes what will happen is we'll notice that a particular test is poorly written or it's flaky for some reason. And so we'll add this text called flaky next to it, right? Cool. It's out of the main path of jobs because like all of the release blocking jobs specifically exclude end-to-end tests that have tags in their name like slow, disruptive, flaky, feature. The problem is we don't actually have another set of jobs that runs the flaky tests under the same conditions that were making them flaky in the first place. What we instead do is send the flaky jobs off to a job that just runs send the flaky tests off to a job that just runs the flaky tests. And since a lot of these flakes only exhibit themselves under load, they look like they're good. Like, look, if I go search for flaky, oh wait, I'm finding everything else. Wait, I should use search. Flaky. Oh my God, there's so many flaky things. What if I just choose GCI, GCE flaky? I think that's what I'm looking for. Look, they're all green. They're all green. 100, okay, not 100% of the time, but like they're a lot more green than some of the other jobs I've been showing you up here. And the reason is because we're not running them at the same time as everything else. We're not reproducing the problem. I really feel like we need some jobs that actually try to cause flakes to happen and reproduce the conditions that would cause them to happen rather than cordoning them off. Otherwise, there's no way we're going to know whether or not we actually fixed the reason it's flaky. Like for this event problem here, wherever it is, for this, where if we could go through as human beings and take a look at all the end-to-end tests and find the ones that have events and then rewrite them, like how are we going to know this actually worked and improved the state of the tests, right? Well, maybe as humans we could notice all the tests and capture all the test names and then go use triage to search and see like how many times those things failed. But I would really love to actually prove that these tests are flaky by making them flake in a place that's like not exactly release blocking, but gives me good information. And then I can fix it and then see that they go green. Your hand was raised.
I just want to let you know you got like 6 minutes.
Okay.
Could we like have a cluster that was super, because it seems like a lot of the ones I've encountered like have been like they flake under like cluster stress. Like if you're running other tests in parallel at the same time or stuff like that, could we just have a cluster where we could, or like a cluster configuration where we could be like, run this test while also running a bajillion other workloads?
Yeah. I think that's what I'm driving at. And since we're at 6 minutes, I'd really rather I not be the one doing all the talking because I want us to walk away with things we can do. I've shown a couple issues, but okay, Ben's got his hand up over here.
I actually want to loop back to something that Dems mentioned, that people do come to us because they don't know what the tests are either, because they're not their tests most of the time.
Yes.
I've been looking at this a lot, and I think the reason is that we don't write tests to be read by anyone else except the direct approvers in that domain area.
Yes.
I think generally as a project, a lot of our code is not really written to be read by people that aren't already familiar with it, and it's especially true for the tests. I think we could deflake things a lot if we could push to write tests that are meant to be read and understood by everyone in the project, so that when someone encounters a flake, they actually have a shot at figuring out what's going on.
Speaking of the domain experts, I did just want to point out, this was something I called out in my earlier session, the test grid config does allow for an option to send an alert to an email address if tests that were once green are now red. You can also configure how many failures in a row have to happen before you send this email out. This is something I am going to require as part of the 1.14 release. If you want your job to block the release, that's the most painful thing to us as a community. I think it is completely reasonable to expect that there must be somebody on the hook to fix those test failures. And they cannot be me, because I'm a bit too busy running the release team. They can't be the test infrastructure people, because they're too busy actually keeping the tests up and running. It must be the people who actually wrote the tests themselves. What I'm interested in is like how we can make sure we're surfacing the right information so people understand like where to go to fix things. And finding the right people to fix their things is definitely step one. You know, we've encoded some of that information in the end-to-end test names with SIG-foo, SIG-CLI, whatever. Another thing you could definitely help out is find there are definitely still some tests that don't have that information embedded in their name, and we could add that to make it easier to route. Something I tried to do as a CI signal lead back in the 1.8 days was to make it really clear if it's not the test owner's fault, it might be the job owner's fault. So like having an email address to send to is certainly one way of signifying that ownership. Where the file lives in the configs of jobs might be another way of signifying that, and which dashboard it lives in under test grid might be another way. It's just a little bit more difficult when we have the SIG release dashboard. I don't know who like the Bazel build master job belongs to, or the GCE job is definitely kind of finicky because that's really where everybody's test cases run. Anyway, time check.
4 minutes.
Okay,
Does anybody else have a question, comment?
Josh,
Yeah, I would say
Mike.
one of the areas where I had the most trouble is jobs, where it's like the overall job is failing. We can't identify a specific test that's failing. And the overall job doesn't belong to anyone. Like it was written by some group that no longer exists. Or nobody can remember who actually created the job.
Yeah.
A bunch of the upgrade and downgrade jobs fall into that category. And so, you know, once we've eliminated the individual tests as the root cause of the failure, then we don't know where to take it.
Yep. Okay. This is something I encourage you all to think about over the next couple of days. Like I said, I feel like I've heard this conversation a lot. I think Brian Grant, when he's like release quality is super important as a priority, technically speaking. I agree. I think it folds into how we cut releases. I think it folds into the architecture of Kubernetes as a project as well as a community. How do we organize ourselves to make this work? So I want this conversation to happen repeatedly. I want to feel like I'm repeating myself, but then I want us to kind of rally together at the end and figure out what we as a community can do over the next year. Like, let's set out that strategic vision and stop being irresponsible or having these bad habits. I personally have started to get a little more banhammery about trying to like kick things out if I don't think they're useful to me. I'm going to have a very specific focus on what helps me ship something in the next quarter as a release lead. And if you help me out, I will be very thankful and appreciative in that regard.
The only other thing I can say is
Just don't do a /retest and move on. Do a little bit more, please. If every one of us does a little bit more, it'll help.
Yeah.
Like opening an issue or just looking at an initial log. Do something a little bit more than just a /retest.
Yeah, I definitely in that vein. Like there was a pull test integration test volume provision thing that was failing similarly, and I ran into it a number of times. And the way it worked for me is the first time I'm like, that's annoying, retest. Second time is like, that's annoying. Is anybody else experiencing this? Yes. Okay. Is there an issue for this? No. Okay, I'm going to make an issue for this, but I kind of don't have time to troubleshoot it more than that. I think because it has the word volume in it, it might be storage's problem. I'll go tag them. Next time it happens, I go back and I finally use triage to start digging in. I find the actual failure text. I also happen to use test grid to figure out these things up here are the actual commits. You can, I don't know if this will work here. Nope, can't do it here. You can actually take these commits, plug them into GitHub, get a diff view to see the PRs that landed, and figure out who do you want to go talking to, because it seems like it used to pass, and now it's not passing. That gives you a list of people to poke. I eventually found the right author of the test and poked them, and that actually got it fixed. So that's at least the process I have used of like gradually investing a little more effort in pushing the ball forward.
Okay, we're actually out of time pretty much. So.
Okay. Yeah. Let's talk afterwards.
True, it's
Thank
just
you.
a break. So.
Yeah.
If you don't need a break.
Oh, if you don't need a break, because I sure didn't. Yeah. I walked directly across the room to here. Yes. Click search for changes. Okay. Oh, I need to highlight it. Click drag. It's not working quite. Hang on. Yes, I'm trying that. Oh my God, what's happening? How do you even computer? Yeah, something's stuck. I promise there is some way you can like, whatever. Yeah. Yeah, I really should be able to click and drag for this. I don't think I'm going to be able to show you. Yeah, that's way too many. Anyway, put a random SHA at the other half of this, and you get a view like, this is going to take forever to render. It's trying. Cool. You get something like this that shows you, wow, that's a lot of red X's. That shows you all of the commits that landed in between one commit and another. This is why it's kind of important to make sure you catch it when it goes red to green. Another thing I'll often do in that vein of like troubleshooting stuff is I will try to find the first time the failure happened or the first time it started to be really, really flaky versus the last time that it ran successfully. That's also really helpful for people to try and troubleshoot what's going on. And then finally, I don't know if the talk has already happened or will be happening at some point, but you may have heard of this thing called kind Kubernetes in Docker, which isn't necessarily the same thing as a massive cloud with lots of VMs that have a totally reliable network. But we do think that maybe using kind to really stress test rapidly might be another way we could uncover some flakes. And it definitely facilitates the question of like, I want to debug this end-to-end test, but I don't want to spend hundreds of dollars standing up clusters in GCE just to make sure like I didn't break the test as I was refactoring it. So that might be another thing you want to talk to Ben the Elder or James Munnerly about, or me, because SIG testing, it's a SIG testing project. Those guys, I'm pointing at them. Okay, I think I want to break now.
Yeah, there's another unconference in here in 10 minutes, or 8 minutes now, so
Cool.
probably best if we leave.
Thank you, everybody, for attending. I'm thrilled to see there's this much interest in deflaking Kubernetes.
Can we automate that process of like teach a bot to like figure out who might have been the that you might want to talk to bot? Like
I would like to. It's very